Hi. So as you can see, like you, I've been banished from campus. We're not going to be doing labs in the very nice lab rooms that we have in ISEC. We're in my basement rec room, which is being repurposed as a lab for the duration of this course. So I'm going to talk to you about how to do sort of the basics of the first lab activity we're going to do, which is looking at the diffraction of light using a laser pointer. Now this is going to be a bit of, catch as catch can sort of situation. You're going to have to make do with whatever you have to hand for doing this lab. I have a whole bunch of laser pointers because I'm a nerd and I have these. So the one I'll be using for the demo purposes is this pen style one that is has a button on the back that turns it on, and it's a green laser. I'll use that because it shows up really well. To do the lab, you're going to want to mount your laser somewhere where it can be fairly stable, and it will have a long path that it can travel along to best show the effect. I have built a little holder for my laser here out of a selection of Lego bricks that my kids have. So that's what I'm going to use to hold the laser. When we get this positioned, I'll tape the laser mount down so that it's stable. You don't want the laser moving around because you don't want it, going into the eyes of your little brother or your cat or anything like that. So you want to secure it to the table, and then it'll always be in the same position, and you know what you're going to be looking for. Okay. The other thing we need to do is to prepare our targets. One target is going to be just a thin, opaque vertical obstacle. So I have this round-headed pin here stuck into a couple of Lego bricks. That'll be one of my targets. The other set of targets is to make a single slit and a pinhole. To do this, I've got a piece of paper here that I'm going to mount on a little frame that I made of Lego bricks. To make it a little easier to figure out what's going on, I'm going to put some marks on the paper to show where the slit is and where the pinhole is. So, I drew a vertical line to indicate the position where I'm going to put the slit. I drew an X. I'll put the pinhole right at the center of the X. To make the slit, you want it to be kind of as narrow as you can get. So I have a little Swiss Army knife here that the TSA regards as a deadly weapon. I'm just going to take that and cut down along the marker line that I drew. Make a single cut. You should be able to, if you hold it up to your eye and look through it, you should be able to see a little bit of light through it because that's the point. We're going to want to get a little bit of light through it. To make the pinhole, I have another of these round-headed pins, and I'm just going to take that and poke it right through the center of the X here, or somewhere close to the center of the X. And then I'm going to take this thing and tape it to the Lego frame that I made to hold these things. So it's this thrilling experiences in experimental physics watching your professor scotch tape things to Lego bricks. For setting up the laser itself, right, I have my little holder here. I'll turn the laser on and aim it across the room. You can see a green spot on a piece of paper I've taped to the wall over there. I've put that in position so that I know exactly where the laser is going to be and it will show up well. I'm going to take some more scotch tape here and tape down my little Lego mount for the laser so that it is stable and doesn't move around. All right, and now you can see, if you look over there, you can see the spot on the piece of paper. I've put a ruler across there so there's a length scale to look at when I do these for making the class slides. For doing the lab, what you're going to want to do is put a piece of paper there that has your name written on it. That's how I'm going to know that you actually did the experiment and got the results that we're looking at. Once you've got that set up and you've got your obstacles, your targets mounted in these highly sophisticated mounts, all you have to do is introduce the target to the beam. So if I take this pin and just sort of slide it in from the side, you can see when it hits the when it gets into the laser beam, the pattern on the paper at the far end changes. You can also see the light that's reflecting off the shaft of the pin where it's hitting. I can slide this back and forth a little bit to get sort of the best, brightest, most dramatic pattern over there on the far side. When you do this, you want to make sure that the laser is traveling at least 6 to 10 feet across the room onto a screen to get the biggest, clearest pattern that you can. That's the inserting the single obstacle. For the pinhole or the slit, right, I do the same basic thing, but I'm putting in a piece of paper here and slide it back and forth until I see light showing up on the screen down there. In this case, I think the slit isn't quite wide enough, so I will use my deadly knife here to widen it a tiny bit and make that a little easier to see. So if I do that, see on the paper down there, you see sort of a broad line. What you're going to see in this experiment is not a simple shadow, but you're going to see a dramatic change in the pattern of light that the laser is making on the paper that you're projecting it onto. And that is going to be something indicative of wave behavior. What we're going to ask you to do is to write down some simple descriptions of the patterns that you see for these different objects, and to take a picture of this or draw a picture of this in some sort of electronic format, and then you're going to upload those photos to Nexus so I can see what your results look like. This is a pretty straightforward, fairly simple experiment, I hope. And it's something that you can have a little bit of fun with. So, try some different objects. I set this up with a pin because that's fairly large and easy to do. If you have longer hair than I do, you can take a piece of hair and tape that across the frame. That'll get you a more spectacular result than these straight pins that I have. You can try anything you like that you have lying around. Generally speaking, the smaller the better. The smaller the pinhole you can make, the clearer the pattern you get will be in the end. The smaller the slit you can make, the clearer the pattern will be. The thinner the object that you can insert into the beam, the clearer the pattern will be. But, play around with it a little bit, have some fun, and hopefully you'll see some nice, clear results from this experiment that will turn out to convince you that light behaves like a wave. And after you've done the quiz where you can enter your text results and uploaded the files with the photos, that will unlock a video in which I explain what all of this means and why this shows that light behaves like a wave. So good luck, and we will see you next time.